And then technically that happens every 2 pi n. And then because it was cosine 3 theta equaled 0, I need to divide everything through by 3. So theta equals pi over 6 plus 2 pi over 3n. And theta equals pi over 2 plus 2 pi over 3n. So what is the first value at which, so this, if you trace this graph, you're starting at theta equals 0, and I just want to know the first value of theta that I hit the pole. Pi over 6, right. So 1/2 integral r squared Now, what portion of that total region does this integral give me? 1/6. So I would want to multiply the entire thing by 6. Okay, go ahead and type that into your calculator. Make sure that you can get that correct answer. You just want to evaluate the integral on the home screen. Do you need to use theta on the home screen? No. If you're on the home screen, I would just replace that with an x. Okay, the reason it doesn't look perfectly symmetrical is because your calculator is a rectangle and not a square. And so it's going to pull everything kind of long ways. But it's just the nature of polar graphs is that they are symmetrical to each other. Yeah. Okay, I forgot a comma here. Okay, it was 1/2, but instead of typing 6 times 1/2, I just typed 3 times the integral. So either way, you should get 25 pi over 4. Okay, now over here when I solved this equation equal to 0 to figure out where that graph hit the pole, the beauty of picking the correct, or picking the easiest region to find that area of and then multiplying it according to the symmetry is that if you pick the right region, then all I had to do was find this first, basically pi over 2 value and divide that by 3 and get the pi over 6. I didn't have to find all of the general solutions there. So if you kind of think ahead to what would be the easiest region to find the area of, and usually it's from 0 to the first time it hits the pole, then you don't have to go through that whole general solution stuff. All right, we're going to find the area of the region that's common to the interior of both of these two graphs. If you happen to have 2 different colored pencils, that might be beneficial. All right, let's graph the first one. Okay, and the only reason I'm going to graph just one of them first is I just want to be able to distinguish the 2 graphs. So there's my first one. It looks like an oval, but what is that really a shape of? It's a circle. Good. All right, so I'm going to use a red pen to graph this circle. And now I'm going to add the other equation onto my calculator. The second one is kind of a sideways heart, which is appropriate now that we're kind of near Valentine's Day. All right, and then I want to find the area that's common to the interior of both of them. So in here. And once again, these are perfectly symmetrical, so I'm actually just going to find the area that's common to like the top half right there, and then multiply that times 2. Okay, now a good strategy when you're doing these, whenever you have 2 graphs, is draw a line that goes from the pole to the point of intersection of the 2 graphs. Oop, I didn't quite hit that point of intersection. And that's going to divide it into 2 regions. And if you'll look at this line that goes from the pole to that point of intersection, then one of the regions is that line, and then my red graph, or my circle, it's bounded by that. And then the other region is my line that I drew and the second graph, or my blue graph that I've drawn right there. And that's going to help us kind of distinguish how we're going to do that. The first thing, so basically we're going to take this red circle, and we're going to, its limits of integration are going to be between here and here. The two, like, well, because that's the boundary of my region that's bounded by the red part. So that's the graph that I'm going to use between those two limits of integration. And then when I switch over, as I trace this out, as I switch over here to the blue graph, I'm going to integrate that from that point of intersection down to there. All right, so we need to find out what that point of intersection is. So how do I find that point of intersection? Right, it's a system of equations. They both equal r, so I can set them equal to each other. So -6 cosine theta equals 2 minus 2 cosine theta. How do I solve for theta? Okay, add 2 cosine theta to both sides. Divide by -4, and I get the cosine of theta equals -1/2. All right, in what quadrants is cosine negative? Second and third. Look at this graph. Where are my points of intersection? Second, third. All right, angle that has a cosine of 1/2 is pi over 3. So in the second quadrant, that is 2 pi over 3. And in the fourth quadrant, it would be 4 pi over 3, but I'm really just dealing with this top half, so I'm only going to deal with the 2 pi over 3. Let's go back to the red circle. Okay, the reason I drew the line is that I need to find the area, because this area is bounded on one side by the red circle and on one side by the blue circle, I had to basically cut that area in half or divide that area so that I got an area that's bounded by the red circle and an area that's bounded by the blue circle. And so, and we're no longer talking about rectangles that go down to the x-axis. You've got to be thinking about sectors of a circle as you go around angle measures. So that's why I had to draw that line. Because I think it's easier to see if you draw that line. Okay, if you don't want to draw the line, then don't draw the line. But for most people, I think it's easier to see. Okay, so the red boundary goes from here to here. I need to find the angle measures that trace out this red graph from here to here. The top part is 2 pi over 3. What's this bottom angle measure down here on the red graph? How'd you get pi over 2? That's right. Okay, because it's, okay. And see, that's the thing, is that some people can just look at that and say, because it's just sitting right there on pi over 2. Okay, why wouldn't it be pi, or why wouldn't it be 0? Or basically because it's kind of, think of it as a circle, and it's almost kind of like that axis is a tangent to the circle where it hits it. Okay, here's another thing. This point right here is also at the pole. The pole has a radius of 0. Okay, my red circle is r equals -6 cosine theta. So 0 equals -6 cosine theta, or cosine of theta equals 0. What angle has a cosine of 0? Pi over 2. Okay, so I'm going to integrate from pi over 2 to 2 pi over 3. Yes, so this is just for the little section that's bounded by the red circle. So therefore, I'm going to do 1/2 integral of -6 cosine theta, quantity squared, d theta. Okay, and then once I hit that point of intersection, I'm moving over to my blue graph. So if I were to trace the blue graph around that edge of that boundary, I would be integrating from 2 pi over 3 until I get down to here. And what's that angle measure? Pi. Hopefully that's much easier to see that that's pi, because when you put in your 0, pi over 2, pi, 3 pi over 2, that's where pi shows up. Okay, and then that one was 2 minus 2 cosine theta, d theta, up squared. Would that give me the answer? No. What do I need to do? Multiply by 2. All right, if you were to type that into your calculator, it might take you a little while, so we're not going to do it, but it would be 5 pi. Okay, now the reason that I drew that line in there, and it's easier to see it for the second part, the blue graph, is that, remember, what we're trying to do is we're trying to find the area of an infinite number of sectors. And so it's easy. I wanted to kind of draw in several of those sectors right there so that you could kind of visualize coming around from 2 pi over 3 to pi and finding those sectors. It's harder to see on the other half of that graph. But I think that line helps some people visualize it. If you didn't want to divide it up into 2, or just do the top half of the region and multiply the whole thing by 2, we could have approached this in a little bit different way. We still would have done the red graph from pi over 2 to 2 pi over 3. But if I'd wanted to go all the way around through here with the blue graph, what would my limits of integration have been? 2 pi over 3 to whatever that is, which was 4 pi over 3. And then I would have had to have gone back to the red graph and gone 4 pi over 3 to, what do you think would take me? And see, I think that's why it's easier to have this, like, draw that line there. So you've got, so you went 2 pi over 3 to 4 pi over 3, and then pi over 3, I'm sorry, the 4 pi over 3 back up here. What do you think that angle measure would be? It'd be 3 pi over 2. Because that's where cosine of theta equals 0 again. So it's just an alternate way to do it. Okay, look at number 6. Draw me the picture on your calculator and then draw it on your paper and find any necessary points of intersection that you would need to work the problem.